Okay, so again, this is a video about question number 4, where you have a list of data and at the same time you are to graph this. You have to graph this relationship. Again, you have to make sure that you want to pick appropriate scale. Now, the one thing about this here, which if you compare to question number 3 is different, is that the ordered pairs are not organized. As I said in class, it should be in ascending order. Smallest pair should be on top, larger pair should be on the bottom. So what I'm going to do is I'm going to write on the side here. Now, write on the side here the ordered pairs. Now, so that it is, again, neatly in ascending order. Then in this case, it would be a lot easier for you to graph a little bit later. Okay. So again, number of balls and mass, which is G. Okay, so the lowest number is 0, 0. So that's fine. Done that. Now the next number is 10. So 10 and 5. Now, when I say smallest number go up, I have to make sure that you're talking about the smallest from the X column in the independent variable column, and whatever it is goes with this number, okay? The next one is 22, so 22 and 22 go with 15, okay? So that's good. Next one up is number 30, and 30 goes with 20. And then after that, you have 38, goes with 25. Last but not least, you have 47, go with 33. Okay, so now I have reorganized this so that it is ascending order. Now, what I'm going to do is I'm going to label the axes including units. Okay, so x-axis will be number of balls. So number of balls. Okay, number of balls. And now, again, I want to look at find out, pick a good scale. So I'm going to use the maximum value, which is 47. So 47, again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You have 10 ticks. Another way to call that is increments. So I have 10 ticks to go up to 47. So 47 divided by 10, which would be 4.7. Now, that would be a horrible number to try to put that as a scale, so I'll round this up to a 5, okay? Typically, factors of 2, 5s, and 10s are good scales, okay? So in this case, this would be 0, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Okay? And in terms of the y, now in terms of unit for balls are individual things, so there's not really a unit. Okay? Now on the y-axis, you have the mass. So again, all right, mass, probably mass of all the balls. Bracket G, because that's grams. So again, I have 1, 2, 3, 4, 5, 6, 7, 8 ticks or 8 increments. And the maximum value is 33. So 33 divided by 8, that would be 4.125. Again, that's a horrible number to pick as a scale. So let's round this to a 5, okay? So 5, 10, 15, 20, 25, 30, 35, 40. Okay? Now, what we're going to do at this point is we're going to graph each point. So again, just like before, you're supposed to use point and then you have circles. So 0, 0, so point, circle. When you have 10 balls, it goes up to 5. Oh, this is nice. Point, circle. When you have 22 balls, so 22 with slightly like a little bit, almost halfway from between 20 to 25. So let's just say about here, 25, 22, and then 15. 15 is in this line, so this is good. 30. 30 goes with 20. Okay, this is nice at the corner. That's fine. 38. 38 is about here between 35 and 40, so it's kind of right in the middle here. And then you go up to 25. All right. And then 47. 47 is kind of right, almost this part between 45 and 50. And you go to 33. Now 33 will be kind of in between 30 to 35, so roughly there. All right. So I've labeled according to axes, chose a data point. I put the data points. Now I'm going to do a title. Now, if you remember, our pretty standard template will be your y versus x. So in this case, your title would be mass versus number of balls. Okay, so that would be good. And draw the line of best fit. Now, this earlier graph, it was supposed to be a smooth curved line of best fit because that's how the data looks like to be. For this one, you can kind of tell that you can probably do a linear straight line. Now remember, when you're drawing a linear line of best fit, what you want to do is you want to draw a straight line that goes through or goes as close to as many points as possible. So if I do it around here, that would actually be a pretty good line. Might not be perfect, but it would be pretty good. One thing you can tell is that I'm touching at least most of the circles. Okay, so I'm looking at it. It's pretty good. So this will be the line of best fit. Now, again, the reason why you want to use the line of best fit is because you can use this line of best fit to estimate the numbers that is in the middle that you actually don't have. So in this case here, even though we don't have the mass of 20 balls, we have the mass of 20, we only have mass of 22 balls. What we could do is I would look at this line of best fit at 20. This should be around here. Now this looks kind of close to a 14 gram. Okay, so this will be about 14 gram because at 20 balls and along this line here at the line of best fit, that is at 20, it goes to about goes to close to about 14. Okay, and B here, use your line best fit determine how many balls will have a total mass of 40 grams. Now, as you can see, we didn't go anywhere higher than 33. Okay, so we didn't know like how many balls would it be to get 40 grams, right? But our line of best fit would help us to be able to do that. Now, the issue with this is that this would actually go beyond our scale. Will go beyond our scale. So let's see if I extend this line any further. So imagine if I extend this line further. If I extend this line further, so that it goes all the way to 40, goes all the way to 40. What I will do now, each of these space is a 9 millimeter. Okay. Yeah, so from here to here, that's about 9 millimeter. So I'm going to look between this spot and this spot. This would be 9 millimeter, so that would be up to 55. So this would have been around here, that would be about 55. So at this point here, after that, another 9 millimeter would go to, this would be roughly 60. So if you're talking about between this point and this point, this point here, this will pretty close, I would guess about 57. Okay, so this here would be about 57. Okay, so using a line of best fit, if I extend this line, so it goes all the way to 40 grams, extend down here, this would look something like 57. Okay, so 57 balls, about 57 balls. I might be a little off, but I shouldn't be too far off. It really depends on how good I draw my line best fit. Okay, now let's see what happens if I do it. Oh yeah, I can't do that. So I was going to show you how it would look on a computer, but I'll perhaps have to add that in a different video. Okay, so hopefully this helps. If you have any question, make sure you ask. All right.